Chapter 9, still in Chapter 9, identifying conics. Oops. Conics. So we're going to learn two methods to figure out when we get an equation what kind of conic we are looking at. So it might be an ellipse or a circle, hyperbola, or a parabola. So the first way we're going to look at is we're going to use the discriminant. So the discriminant, if you remember, we used with parabolas to see what kind of solutions we might have with a parabola a long time ago. And now we're going to use this in a very similar way. So we're going to use the discriminant, but it looks a little bit different than it did back. Oops, there's an A here, not an E. The discriminant. So first we need to see what standard form looks like. So we're going to look at ax squared plus bxy plus cy squared plus dx plus ey plus f equals 0. So this is the form that we need our equation to be in order to use the discriminant. Now, we're going to write out what the discriminant tells us for each parabola, circle, ellipse. All right. So the discriminant is b squared minus 4ac. So if this equals 0, then you have a parabola. If b equals 0 and a equals c, then you have a circle. If b squared minus 4ac, remember that's our discriminant, is less than 0, think negative number, and either b does not equal 0 or a does not equal c, then you have an ellipse. And the last one here, I have my discriminant. It's greater than 0, meaning it's positive. Then I have a hyperbola. Alright, so that's using the discriminant. So let's maybe do an example of what that might look like. So let's say I've got y squared plus 2y plus x squared minus 24x equals 24. So now I've got to put this in the standard form up here. So I'm going to put the x squared in the front. And then xy, I don't have any xy terms, so I'm going to say plus 0 xy. And then what comes next, the y squared one, so plus y squared. And then I've got the x term here, minus 24x. And then I've got the y term plus 2y. And then plus f here. And since this was equal 24, I'm going to subtract 24 from each side. So I've got minus 24 equals 0. I want to have equals 0, and so I subtracted 24 from each side to get that constant f there that doesn't have a variable next to it. Now I'm going to say this is a, and this is b, and this is c. So those are the only terms I really need when I use the discriminant. So b squared is 0. Oh, look, I might have a circle here. So a is 1, b is 0, c is 1, right? The 1 goes before the variable there. So I have this instance here where a equals c, a is 1 and c is 1, so a equals c, and b equals 0, so I have a circle. Let's do another one. Let's try this one. 4x squared plus 8x plus 5y squared minus 30y minus 11 equals 0. Alright, so let's get this in the standard form. So I've got 4x squared, and then I need an xy term. I don't have one, so I'm going to play plus 0xy as my placeholder there. And then my y squared term plus 5y squared. My x term plus x plus 8x. And then my y term, which is minus 30y minus 11 equals 0. Now I've got it in standard form. There's my a value, my b value, 0 again, and my c value is 5. Okay, so it looks like I need to plug this into my discriminant here. So that's b squared, 0 squared, minus 4 times a, which is 4, times c, which is 5. Alright, so 4 times 4 is 16. Oh, I'm going to do this one. This is easier. 4 times 5 is 20. 20 times 4 is 80. So I've got negative 80. That's my discriminant there. So if I have a negative number for my discriminant, then b doesn't equal 0 or a doesn't equal c, then I have an ellipse. So this is negative, and b does equal 0, but a does not equal c. So I have an ellipse here. Alright, let's have you guys do one. 4x, minus 8 plus y squared plus 4y equals 0. Alright, let's get this in standard form. I don't have an x squared. Alright, so I'm going to say 0x squared. And then I need an xy term. I don't have an xy term either, 0xy. And then I've got a y squared plus y squared. And then plus x, my x term, plus 4x. And then my y term plus 4y. And then I don't have an f. Oh no, I do. Minus 8. There we go. Then minus 8 equals 0. Alright, did I do that right? So I don't have those two. 1, 2, 3, 4. Alright, so now I can look at this and I can see I think I have a parabola. And the reason I think I have a parabola is because I have y squared and I don't have an x squared. So if you remember standard form of parabola, one of the variables is squared and the other one is not. And so let's go through the discriminant here and see if I'm right. So I've got, this is a equals 0, b equals 0, and c equals 1. So if I say 0 squared, oh, you're supposed to pause this because this is a U try. Oh well. 0 squared minus 4 times a, which is 0, times c, which is 1. 0 times 4 is, and 1 is 0. 0 squared is 0. 0 minus 0 is 0. 0 is my answer. So if my discriminant equals 0, then I have a parabola. So parabola. All right, that's how to use how to identify a conic using the discriminant. Now let's identify a conic using standard forms of these. How do I want to say this? Yeah. Let's call it by writing the equation. Oops. Probably a better way to say this, but we'll just, for now, that'll be it. All right. So what we're going to do here is we're going to take an equation, and then we're going to put it in the standard form of either the parabola or the hyperbola or the ellipse or the circle. And as we do that, we will find out what kind of a conic this is. So let's start with this example. 3x squared minus 4y squared minus 30x minus 8y plus 59 equals 0. So here's our equation. I've got an x squared and I've got a y squared, so I know this isn't going to be a parabola. So the first thing I want to do is I want to get this ready to be in standard form. So, this one's, all right. I'm going to subtract 59 from each side. And I'm going to group the x's together and the y's together. So I'm going to do that both in the same step. 3x squared minus 30x minus 4y squared minus 8y, and I subtracted 59 from each side, so I have minus 59. Okay, so I'm just grouping the x's and the y's together. Now, I am going to look at this, and I can factor out this 3 that's in front of the x's. So I'm going to say 3 times x squared minus, minus 10x. All right, and I'm going to leave a little space here because I'm going to do something right here. I can do the same thing with the y. So minus 4, because there's a 4 here and a 4 in the negative 8. So, and I'm taking out a negative 4. So y squared plus 2y equals negative 59. So I'm going to do something here as well. So I'm going to start completing the square here. So I say, what do I say half of this number, 1/2 of it, and then I square it. 1/2 of this number and square it. All right. So not x, whatever. Okay. So 1/2 of 10, negative 10 is negative 5. Negative 5 squared is 25. So I need to add 25 in here. We're going to look at this again in just a second. Same thing here. Half of 2 is 1. 1 squared is 1. So I'm going to add 1 here. Now, when I add 25 in here, I'm really adding 25 times 3 to this side of the equation. So 25 times 3 is 75. So I've added 75 to this side of the equation. What do I do to this side? I do to the other side, plus 75. So 25 times 3 is 75. So I need to add 75 to both sides of the equation. Same thing with this one. I've added 1 here, but I've really added 1 times negative 4. So I am adding a negative 4 to this side. I also need to add a negative 4 to this side. All right, so we could say this is 3 times 25, and we could say this is negative 4 times 1. Either way, that's how we end up with those numbers on the other side. What I do to one side, I have to do to the other side. That's the hardest part of this whole completing the square right there. Now, this expression here is a perfect square now, because what I've done here by adding this 25. Same with this, a perfect square. So I'm going to rewrite this as 3 times x minus 5 squared. If I were to FOIL x minus 5 times x minus 5, I'd end up with this. Where did I get that minus 5? The negative 10. Half of negative 10 is minus 5. Minus 4 times y plus 1 squared. Half of 2 is 1. That's the one that's going to go there. Equals, now I've got to add all this stuff up. So negative 59 plus 75 minus 4 is going to get me 12. Positive 12. Whew, we're almost done. So now all I need to do is I need to divide everything by 12 because I want a 1 over here. So divided by 12, divided by 12, divided by 12. Everything gets divided by 12 because I want 1 here. So 3 divided by 12 is 4. So I have x minus 5 squared over 4 minus y plus 1, oops, squared over 3 equals 1. All right, now I have my standard form, and I need to know what this is. So remember, with an ellipse and with a hyperbola, this number over here is 1, and then we have denominators here. If this is positive, then I have an ellipse. Since this is negative, this tells me I have a hyperbola. So I have a 1 over here on the right, and a negative, a subtraction here, and I've got stuff in the denominator. This is a hyperbola. Now, if both of these numbers are the same, then I have a circle, because these I would just multiply and then I would end up here. But this would be plus if this was a circle. Let's see, should we do another one? Let's just write down the standard form of each of these. We probably should do another completing the square here. Let's do another one. Let's write first what these standard forms look like of each equation. So I've got let's do a parabola, ellipse, circle, hyperbola. So a parabola, remember, looks something like this. I've got x minus h squared equals 4p y minus k. An ellipse will be, and these x's and y's can be switched just as long as one's squared over here and one's not squared over there. Right, so it could be y minus k squared equals 4p x minus h. All right, and ellipse now would be x minus h over a plus y minus k over b squared, right? These should be squared, equals 1. And we can switch the x minus h and the x y minus k there. The circle, oh, these should be squared as well. Let's get this right, Mr. V. All right, now my circle should look like, maybe I should go like this, so it makes it a little easier. Will be x minus h squared plus y minus k squared equals r squared. Or if you have the same denominator, then you just multiply everything by the denominator and you end up with r squared, right? So I would say a equals b here. Hyperbola looks just like the ellipse except for one thing here. So hyperbola looks like this, x minus h squared over a squared minus y plus k squared over b squared equals 1. So I've got all of those different conics there. And this is, once you get to this form, then you can see which conic you have. So let's just do one more. Let's go ahead and let's do this one. All right, this looks like one more example. Let's do this. This should work out fine. 6x squared plus 24x plus 2y minus 10 equals 0. Now right off the bat, I see I've got x squared here and I don't have a y squared. I know this is going to be a parabola, but I'm going to give you a little practice with completing the square here anyways. So I've got my x's by themselves and my y's by itself. I'm going to add 10 to each side. And I'm going to now pull out a 6. 6x squared. 24 divided by 6 is 4, plus 4x. And then think about what I'm going to put right here in just a minute. Plus 2y equals 10. Since I don't have y squared, I'm not going to be completing the square over there. I'm actually going to subtract this over there in just a minute. But let's just keep going with this completing the square here. So half of 4 is 2. 2 squared equals 4, so I'm going to add 4 here inside my parentheses. 4 times 6 is what I'm actually adding to this side of the equation, so I need to add 4 times 6 over here, which is 24. So both sides I need to add 24 to. Now, I'm going to rewrite this as a binomial. So x times x plus 2 squared. Let's subtract the 2y from each side. Equals negative 2y plus 10 plus 24, which is 34. Okay, so now I'm getting pretty close. If I had two of these squared, if I had x squared and y squared, I would keep them both here on the left. But since I have a y that's not squared, I'm going to put the y on the right because I know I have a parabola here. So now what I want to do is I want to get this y inside a parenthetical statement like this one, y minus k. So I've got 6 times x plus 2 squared equals negative 2 times y, and since I need to factor out a negative 2 from this 34, so that'll get me negative 17. Negative 17 times positive 2 gives me negative 17 times negative 2 gives me positive 34. Alright, I'm almost there. Now I just need to divide everything by 6, or both sides by 6, and I have x plus 2 squared equals negative 1/3 y minus 17. That doesn't look super awesome, but I don't see any errors here, so I think I'm alright. So I've got a parabola. And that's it. That's how it goes. Alright, good luck.